Working with observational data usually puts us in the kind of situation depicted in this figure. An older literature describes this as the pre-test, post-test, non-equivalent control group design, which I'm sure you'll agree is quite a mouthful. That's just a fancy way of saying that we want to make an inference about the causal effect of a treatment, and that we have a control group that we can compare the treated to, but that allocation of the treatment and control conditions is clearly not by random assignment. We've learned that we can improve things by conditioning on pre-treatment observables, but we're never going to know that we have conditioned on all the right things. Does that mean that the game is not worth the candle? It's tempting just to give up and say that nothing at all can be said about causality in this sort of situation. Now, strictly speaking, this may be true, but sometimes we may be able to make some progress by considering the plausibility of some threats to internal validity. Consider the following hypothetical example. A large management consultancy organizes work on the basis of project teams. Each team has a team leader. The senior partners are worried about morale levels in the firm. The decline in morale is indicated by increased absenteeism. They decide that the solution is to allow team leaders to adopt, if they wish, more participatory ways of making decisions. Some team leaders do this, and others don't. The partners, after implementing this program, decide to evaluate whether it's worked. Here is what they find. In those teams that adopted participatory decision-making, absenteeism has decreased, and in those that did not, it's remained at the same level. Is this plausible evidence for an effect of participatory decision-making? The answer is, it depends. Firstly, we should note that at baseline, PDM adopters already had slightly lower absenteeism rates. The difference doesn't appear to be so great, but it is indicative of a relevant difference between the groups. Secondly, we can't rule out the possibility that PDM adopters might already have been on a downward trend. Perhaps those team leaders were inherently more easygoing and democratic. This would amount to what in the jargon is called selection by maturation. We could only rule out this possibility if we had pretest observations for a longer period of time before the study began. The conclusions you would draw would depend on the plausibility of the selection by maturation effect. Without the measurements, we can't rule this out. But perhaps something could be learned in a small-scale study like this by more informal retrospective questioning of the participants. Now imagine a slightly different scenario. Rather than allowing free choice, participatory decision-making is imposed by the senior partners on the teams with the highest absenteeism rates. This is what they now find. Nothing changes for the project teams without participatory decision-making, and a very sharp decrease occurs for teams who have had PDM imposed upon them. It's important to say that we still can't be sure that the treatment has worked, but it is perhaps a little more plausible. Why is that? Consider the threat to internal validity from maturation. It is, of course, still there. We haven't added any pre-treatment observations. But why should differential maturation lead to such a dramatic crossover in the lines? Now consider another threat to internal validity, so-called regression to the mean. Regression to the mean is a process that could plausibly occur if we select for treatment subjects who have extreme scores on the outcome variable. We're all familiar with the idea that sometimes sports teams can just get lucky and achieve success that no one would have predicted. Like, for instance, Leicester City winning the English Premier League in the 2015-16 season. Such teams, however, rarely repeat their success. Likewise, we're all familiar with stories of good luck in examinations. Despite being excessively lazy during the year, some students will have the good fortune to revise just the right topics for the questions that turn up on the exam, and thus do far better than anyone would have expected. This, however, would not be a reason to recommend their study habits. The chances of repeating the success in the next exam would be slight. The point is that high or low scores on a test partly reflect ability and partly reflect chance. If we select a group for treatment on the basis of their test scores, we would not expect them, on average, to maintain the same level of performance. It's possible in our example that we observe in the PDM group a form of regression to the mean rather than a genuine treatment effect. However, we should be cautious about concluding that that is all that is going on. If it's just regression to the mean, why should we expect the lines to cross? Though the effect of PDM is still far from proven, perhaps the case is a little stronger. Sometimes we can use selection into treatment that is based on pretest scores to our advantage in a so-called regression discontinuity design. Say that the top 10% of a company's sales force are given a bonus over and above their normal commission and salary. The management wishes to evaluate whether this has a positive effect on their salesperson's performance. What we conclude in a case like this depends on how things turn out. The slope describes the relationship between the 2017 sales figures and the 2018 figures. We are interested in what happens to that slope for those in the top 10% of the 2017 distribution. If we observe continuity, then it will be difficult to conclude that there has been an effect. If we see a decrease in the slope, for example, these two lines here, then our first thought should probably be that regression to the mean has taken place. If we see a shift in the level of the slope, for example, here, or a difference in the angle of the slope, for example, here and here, then this might be plausibly interpreted as evidence that the extra payment has a positive effect on performance. Sometimes it's just not possible to control who is exposed to the treatment. In this kind of case, the best that we can do is to control when observations are made in a so-called interrupted time series. Typically, we want as many time points as possible, both before and after the intervention. Usually, we aim to have even spacing in the observations if we hope to capture something of the dynamics of the process. With this kind of setup, we at least can rule out the threat from maturation by looking at the pretest trend. We will of course have to consider the plausibility of any break in the time series that we observe. This will normally involve understanding something about the likely leads and lags in any possible treatment effect. Is the sort of process you're studying one in which we might expect immediate effects of an intervention? Might the intervention be anticipated by the subjects? Are the effects of the intervention only going to reveal themselves over a long period of time? To make sense of patterns in a time series, you will have to think these issues through carefully, and of course the details will differ from case to case. I've come now to the end of the section of the course concerned with causal inference. I began in the first lecture in the sequence by making a distinction between examining the effects of causes and looking for the causes of effects. It would be wrong, however, to leave with the impression that these are entirely rival ways of going about things. If one takes a wide enough view in the context of a scientific research program, there is no inherent conflict between them. Searching for causes of effects ultimately yields candidates for more detailed investigation. At this point, one switches to examining and quantifying the effects of the hypothesized causes. Rather than conflict, there is in fact complementarity. What is required, though, is that at each stage one keeps firmly in mind what exactly the purpose of the investigation is. Having a sense of the nature of your intellectual project is one of the things that will help you to choose the research design that will give you the best chance of producing a convincing answer to your substantive question.